Okay, hey, year 10. All I want to quickly do right now is dive through the top 5 questions to address from Mathspace for week 2. So that's going from the year 10 expected algebra skills task, which honestly, there are some really tricky questions in there. So if we go through some of these and you're still a little bit stuck, that's totally fine. It's just the difference between getting like an A and an A plus on a test, right? So all I'm saying is have a look through this if you struggle on some of these questions. If you're still not sure, you can either shoot me a message, email, or honestly, as long as you got the basis of it, it's totally fine. Please don't stress out at home. The other part is factorizing, and luckily these factorizing ones hopefully should be quite nice once we go through them. So we'll jump straight into the first one. This is 11 students that needed help on this, so obviously quite a common one, and it's actually to do with negative indices and multiplying powers. Okay, so the trick here is whenever we're multiplying or dividing or doing something with variables that have powers, okay, we want to deal with the numbers first. So dealing with 5 times negative 4 should just be 5 times negative 4, that's negative 20. And then once they're gone, I'm just dealing with y to the 4 times y to the minus 8. Now, hopefully we remember that when we're multiplying the same pronumeral, we're going to be adding these powers together. So 4 plus minus 8, which gets me an answer of minus 4. Now that is correct, and we could leave it like that, except for the question asks us to write it with a positive index. So what we need to do is change this from being a negative to a positive. We're going to leave that negative 20 on top because he's just negative 20. He hasn't got a power. And remember that a negative power just means that it's on the wrong part of the fraction. So if it's just written as a whole number like it is, it needs to become a fraction and it needs to go on the denominator. And contrarily, if it's on the denominator and it's a negative power, then that needs to come up on top. Okay, so in this case, it's got a negative power, he's not happy where he is, need to move him down, and that's going to be our answer there. Okay, now for this one here, it may look like we're going to do some fraction stuff, and you could approach it through fraction rules. We're not going to, because I think there's a much easier way. What we're going to do is make x the subject, so we're getting x equals whatever, right? So the first thing I want to get rid of is this plus n on 5, because n on 5 in this case is just some number, because I don't actually care what n is, I'm just trying to get x. So the way that I can get rid of n on 5 is just to take it away from the other side of the equation. So I'm going to get x on 2 equals to take away n on 5, and don't be tempted to try and make an answer there. We don't know what n is, so we're just going to leave it like that. Final step, we've got this divide by 2 on our x, and we want to get x just by itself, nothing else. So we need to get rid of this divide by doing the opposite operation, which is timesing by 2 on the other side. The trick here, where I'm assuming most people went wrong, is when there's more than one thing that's being multiplied, so it's 2 and the negative n on 5, we need to use brackets to show that it's all being multiplied by 2. Now, if you write that out, hopefully what you should realize is that, whoops, sorry guys, we're jumping in a minute later. What you should hopefully realize is that we are expanding these brackets. So we're going to be doing this 2 times 2 and 2 times negative n on 5. 2 times 2 is just 4. When you multiply a fraction by a whole number, you can imagine this is like n on 1. So that 2 on 1, that 2 is just going to multiply up on top. So we're going to get negative 2n on 5. There's heaps of different ways to get to that answer. There's also different ways of writing that answer. For example, I could multiply both bits by 5 to try and simplify this denominator. I'm not going to. So if Mathspace does have something different and doesn't want to accept this as your answer, either shoot what you've got to me and I can help you get it in there, or otherwise just leave it. As long as you kind of understand the steps of moving stuff across, you're fine. Okay, so factorizing. The trick with this question is that there isn't actually a number that is common in both terms. It's the pronumeral. But the trick is, if you were just to pull z out the front, you'd be left with a z still in both terms, which is why we have to pull out, when we're doing pronumerals, the highest power of z. In this case, that highest power is z squared. And if I pull z squared or divide z squared by z squared, I'm left with 1. And from that second term, I'd be left with 6. And if I got rid of 2 z's, I'd be left with z squared. And that is my answer factorized. Okay. What we might do is go through this last factorization question and then come back to this rearranging, because it's quite tricky. So we'll come back to that one in just a moment. So in factorizing, okay, we are looking for two things. We are looking for a number that multiplies into both 5 and 40. The only number I can think of would be 5. And if I was to pull 5 out the front, I'd be left with a 1. I'm not going to write, let's write 1. Okay, we'll write 1. And if I divided 40 by 5, I'd be left with 8. Okay, so that's the numbers taken care of. Then what I need to look for is, are there any letters or pronumerals that are common in both terms? Now, this is quite a tricky one because there are like powers involved as well. So you'll notice that there's a k in both parts. Now, the biggest power of k that I could pull out is this k squared, because k squared can fit in, it is less than k cubed, but k cubed doesn't fit into k squared because this is bigger. So the biggest k that I can pull out the front, I'm going to give myself some space, is this k squared. And if I pull that out or divide by k squared here, it would leave me with 1 again. And I could write 1 times 1, but we're not going to do that. We're just going to ignore him for now. Now, if I got rid of 2 k's from that power, because that's what happens when I divide by k squared, I'd be left with k to the 1 or just k. Now we do the same thing with t. This has 1t, this has t cubed, so I can only pull 1t out the front. Again, that's just leaving me with 1, because it's taken out the front, it's divided by that, so it's gone. And then we can pull 1t away from that t cubed, and that would be our final answer. Okay, so now we'll quickly dive into this rearranging. Okay, the last one, we're going to go through rearranging the formula, which is basically solving equations, which you don't know, but Lowback just came in and we were talking about what we're going to do for the rest of the term after this topic is over, and we've decided to do solving equations. So kind of double dipping and using all the skills we're currently working on in that topic. So there should be a bit of overlap, but also questions like this where I'm asking you to do it now because we have to, it's in the syllabus. You're going to get a lot more chances and a lot more practice to solve this kind of stuff. So if this is kind of a bit overwhelming, again, this is probably the hardest question that we're going to go through. Don't stress yourself out. We're going to have heaps of time to do that at the end of the term. Okay, so we'll go through it regardless. The first thing we need to do is we need to realize we're trying to solve for k. What makes this a tricky question is you've got 2 k's. They're in different spots. So we need to manipulate what we can to try and get the k's in the same spot or on the same side, but not on the top and bottom of a fraction, because that's no good. So the only thing I can think of doing here is to get rid of this divide by timesing it on the other side. So if I was to do that, I'm going to have r times k minus 9 equals k. Now, through a bit of intuition, you look at this and you go, well, what can I do now? I could divide that across, but that just gets me back to where I started. So maybe we'd like to expand these brackets and get rk minus 9r. And now you go, well, what can I do now? Remember, we're trying to get k together or on its own. So I want to move this rk over here. The way I do that is by taking it away, because it's just there, so I need to take it away. I'm going to get k minus rk. And now you go, well, what can I do now? Notice that there's a k in both parts here. So if I wanted to, I could factorize out that k by dividing both parts by k. And that leaves me with just 1k. We've kind of hit our goal. And now to solve this equation, I need to get rid of this times by dividing this thing on the other side. Don't necessarily need brackets here, but you're not wrong for including them. And so my final answer is going to be minus 9r over 1 minus r, which is what we leave it on. Okay, look, again, it's kind of great news that the questions you're struggling on are really bloody hard and not the basics, because it means you're all having a really good crack. I will post a lesson later on today. It'll be on the YouTube. All I want you to do is expanding binomial products, so expanding brackets. When you've got two brackets, I'm going to show you what I think is kind of the easiest way to approach it. It's going to be kind of future-proof. And then that's it for this week. I want to give you one task. I want to kind of ease off you a little bit. We're going to go on this pattern of like 2, 1, 2, 1 in terms of lessons per week, because it's so important this week. And I really want you to nail it down without causing you too much grief. So stay tuned for that. And just let me know if any of these are still unclear or you have any questions that I didn't go through. Awesome. Thanks, guys. You're doing a great job. Keep it up.